Let's get started. My project is the DeepID for face recognition. Here is some applications of the face recognition. You can see the Alipay's mobile payment and Apple's Face ID. This is a picture of traditional convolutional neural network. It contains an input layer, a convolutional layer, a polling layer, and a convolutional layer, polling layer, and so on until the fully connected layer and the output layer. The convolutional layer looks like a convolution operator. It can extract the features in the image, and each result can be regarded as a feature. For polling layer, we usually use the max polling layer. It's like a downsampling, and it reserves the sharpness of the image when the pixel is slightly displayed in the neighborhood. The output of the polling layer is unchanged because we only contain the max one. This is a picture of fully connected layer. Fully connected layer, we get every feature to one single value, so we can ignore the influence of the position of one specific feature. Now, this is the structure of DeepID. You can find the different from traditional CNN. It has a DeepID layer. It's connected by the third max polling layer and the fourth convolutional layer. Then we use softmax as an activation function to classify. This method is effective because the higher layer of the neural network, the larger the field of view. So such a connection can consider both local features and global features. Utilizing the third layer as a supplement, we can reduce the possible information loss in the fourth convolutional layer. My dataset is the YouTube face. You can get it from this link. The first step is to augmentate the picture, because different people have different pictures. We need some people have this almost the same pictures, so we do the augmentation operator by randomly adding brightness, contrast, or flip the image and add this image to those people who do not have 600 faces. You can see the left one is the original image and the right one is the processed image. Then we should crop all the image to the same size. Results shows here. And the running environment, I use TensorFlow GPU and NumPy and Pillow. This the step to run the program. First, you should download YouTube feeds and put the database into your folder named image and origin. Then you should run these py files. That's the result of our you can see the accuracy converges quickly, and it's almost 1 during the iteration. So we can see we get a good result, and the loss is almost 0 too. So as a conclusion, I successfully implement a deep ID algorithm training on YouTube feeds database. And by representing a large amount of different identities with a small number of hidden variables, highly compact and discriminative features are acquired. The features extracted from different face regions are complementary and further boost the performance. This project achieved a 98% accuracy on the valid dataset and 96% face verification accuracy on the test set. Okay, let's go to the code part. This is a code for the test of about 3,000 face. So we can run this. We set a threshold to distinguish the people, and the distance is a cosine distance. You can see we have a accuracy of about 96%. This is a field to define our CNS. This is a train field. We can run a little epoch because the time is limited to see the sum results. Okay, let's go to this part. This is a function to define the convolution layer and the max pooling layer. If this attribute is false, we have a convolutional layer and a max pooling layer. If it's true, we only have a convolutional layer. This is the structure of the neural network. You can see the input and output. I write a comment on the right. Then we flat the each layer and add them together to get our deep ID layer. The activation function at the last layer is softmax, and we change the and we change the learning rate every 14,000 epochs. And as the optimizer, we use Adam. Yeah, I add some code such as this to plot the accuracy and the loss pictures. So you can see this is the field to the image augmentation, and this is a field to crop the image to the same size. This is split the train dataset, valid dataset, and the test dataset, and this one is to transfer them to a vector, and we are easy to process them. Then we use train field, but because the training progress is time consuming, so I trained it. I have trained it, so I just run the test field. You can see it trains slow. Okay, at the 2000s iteration, we have got 37% accuracy. That is much better than the only 1%. So you can see the neural network converges very fast. Yeah, I'll use a better battery mode because it causes too many electric. And here we get 16.8% accuracy. And 18.2% just 4,000 iterations. Yeah, here I save the result as an MPY file to plot. Yeah, this is a plot file. I use this to plot the pictures shown in the PowerPoint. You can see we now have a 19% a 90% accuracy at the 5,000th and 6,000th 19.2